In this video, I will discuss the acceleration of gravity, which is through a one-dimensional motion. The one thing up to this point we haven't discussed direction. In physics, direction is pretty much an agreement. It's agreed that motion in the x-axis, this is the x-axis, this is the y-axis. Motion is positive in this direction and negative in this direction. And the vertical motion, which is gravity, is a vertical motion, up and down, positive in this direction and negative in this direction. So if you look at the cartoon next here, the distance traveled by the car is going to be expressed in negative. So the change in distance is going to be negative. Now, if you remember that velocity is the change in distance over the change in time. Change in time is always positive. So you will have, in a vertical motion, in the case of gravity, the change in distance is going to be negative divided by a positive quantity. So velocity is going to be negative. We said here that was distance, so x is positive in this direction and negative in this direction. Since velocity and distance are related, velocity 2 will be positive in this direction and negative in this direction. Consequently, acceleration is the change in velocity over the change in time. Change in time is always positive, and the change in velocity in a vertical downward motion is going to be negative. So acceleration will be negative in this direction as well and positive in this direction. If you look at the cartoon here, it has a claim on the bottom, 0 to 60. I'm going to assume that 60 is meters. 0 to 60 in 3 seconds. It doesn't look much like a problem in physics, but you'll be surprised. It seems to have given more information than you think. 0 to 60 means that the initial velocity is 0 meter per second. The final velocity is negative 60 meters per second, since it's traveling downwards, and the change in time, delta t, is 3, which is actually the initial time is 0 and the final time is 3 seconds. To verify the claim made in this cartoon as true or not, of course, the acceleration would have to be the change in velocity divided by the change in time. Change in velocity is the final velocity, which is negative 60, minus the initial velocity, which is 0, divided by the change in time. Final time is 3, initial time is 0, and that will be negative 20 meters per square seconds. Now, is that true? At this point in the course, we really don't know. Unless we know the acceleration of gravity, we couldn't verify. So let's see the history behind figuring the acceleration of gravity. If you look down here, this is a gadget made by Da Vinci. What he did was he attached 2 wooden boards with a snapping mechanism, probably a spring. And he had a water dropper. As he released the drops 1 second apart, after so many seconds, he snapped the 2 wooden boards and the water drops made an impression. Now, since he released all the drops 1 second apart, delta t was always 1. He measured, this is rest position, and for the first one he measured and he found that it was 9.8 meters. For the second one, from rest, it was 19.6 meters. For the third one, 29.4 meters. 39.2, 49, all these are in meters, 49, and so on and so forth. So let's see if we could figure something out of this. The acceleration. What he noticed also, that the drops, as time went on, increased in velocity, which means there was an acceleration. And he wondered if acceleration was constant. That would be the acceleration, gravity. That would be the force that draws objects towards the center of Earth. It would be delta V over delta T. Of course, he didn't have the velocity, so he had to go find out what velocity was. Velocity was delta x over delta t. And this is an average velocity. Now delta x for the first drop, final distance, was negative because it's moving downwards. 9.8 meters minus 0, place of rest, divided by delta t, which is 1 second apart, so it's 1 minus 0. And the velocity was negative 9.8 meter per second. Now this here is negative because it's moving downwards, not upwards. For the second reading, velocity was delta x, change in distance, over delta t. The final distance was negative 19.6 meters minus initial distance, which is negative 9.8 meters, divided by 2 minus 1. This is the second drop, so it's 2 seconds. And he found that this was also negative 9.8 meters per second. For the third one, for the third drop, velocity would equal the change in distance, which is negative 29.4, minus the initial distance within that 1 second, would be negative 19.6 divided by the change in time, which is 3 minus 2. V was negative 9.8 meter per second square. What does that mean? 9.8 meters per second. Keeps on repeating. Now let's see what that means. That means it accelerates at a constant rate, which means acceleration at any one of these would be the delta, the change in velocity, delta V, divided by delta T. And in any one of these intervals, which is 1 second, the change in time is 1, and the change in velocity is negative 9.8. And that's negative 9.8 meter per second square. Now, since this is a number that keeps on repeating in physics, in motion, it's called g. And g equals negative 9.8 meters per second square. And that's the acceleration of gravity. It's always a negative because it's always acting downwards. And that's gravity. Now, knowing that the acceleration of gravity is negative 9.8, when you go back to verify the cartoon's claim, you realize that the claim here is 20 meters per second squared. And since 20 meters per second squared does not equal 9.8 meters per second squared, which is what we figured G for. Of course, both of these are negative. This claim is false. In 3 seconds, the velocity will be, let's figure what the velocity should be in 3 seconds. V final equals V initial plus acceleration times time. We know that the initial velocity is 0. And we know that the acceleration is minus 9.8 multiplied by time, which is 3 seconds. And if you do this multiplication, you will have negative 29.4 meters per second. That's the final velocity. The claim was negative 60 meters per second. So that claim is false.